Hello guys, welcome back to John's Workshop. This is episode 22 and this is going to be a bit more about the mill. So hopefully a first cut, all being well. So what I've done since the last episode where you saw me completing the build is I've got the wiring sorted out, and we've had a couple of issues with that, which is kind of why I cut the last episode when I did. So I'll just take you through what I've done there, and then I'm also going to take you through the setup that I've done on the mill past the last episode really. So I'll just reposition the camera and we'll have a look at the transformer, and I'll tell you what sort of issues I had with that, and then we're going to focus in on the machine itself. We're going to get the vice set up on it. So it's a new vice that's needed a bit of fettling, and I'll just show you some of that, and then we'll crack on with first little project on the mill, which I'm looking forward to. So I'll bring you back in a moment. Alright guys, so this is the phase static transformer, the phase transformer that goes from single phase to three phase. So when I first got the mill rewired, the motor rewired back up, and we turned it on to give it a go. This thing has a boost circuit on. I don't know whether you can see from there. Let's see if we can zoom in a little bit. There we go. So it's got a boost circuit. So effectively there's two circuits in here. There's a running circuit and a boost circuit. And basically it's full of big power capacitors and a huge transformer and some sensing equipment. And basically what happens is the boost circuit will be part of the huge capacitors in there. And they will charge themselves up so that the thing's ready, and that's really all about starting up three-phase motors, because some of them need a bit more grunt to get them started and get them moving. So that's what the boost circuit's for, and then the run circuit is for just normal running. Now the boost circuit stays on for 2 or 3 seconds. It's variable based on the settings inside the machine. And what I was finding was, as I was trying to start the mill, the motor was making some very strange noises during the period of time that the boost was on. So I bought this unit from a company called Power Capacitors in the UK, and their sort of trade name, which you can't see at the moment because I'm zoomed in too close, there you go, their trade name is Transwave. So these things, I've seen them before in industry in various places I've worked. You know, they've been around for years and years and years, which is one of the reasons I opted for this option rather than a VFD. So basically what was happening, the boost circuit, because this is quite a smallish motor for a unit of this size, was too much for the motor. So I phoned, I emailed, a guy called Pete, who works at Power Capacitors, and said, look, I bought this unit off you, having a few issues. And to be fair, the guy phoned me back the next day, took me right through all of the settings and stuff, so talked me through getting into the cabinet, changing a couple of settings inside the cabinet and sealing it all back up again. You know, really helpful. And you know, again, that's one of the reasons that I bought something from the UK, because I'd got a feeling that things wouldn't go, you know, straightforward. So it's always handy to have that support, and you know, in all fairness, and a brilliant service really from Power Capacitors. He didn't have to help me, you know, I'd already bought the unit, but went out of his way to get straight back to me the next day. So fantastic. So we've tweaked around the settings a bit, and everything's fine now. So we've got power to the mill. So that's one thing. The other thing that I've done is I've set the head up. So last night basically I got a clock on the table spinning, full width of the table, to basically tram the head in, and it took quite a while. So I got about 20 thou of nod, so it was heavy on the front by about 20 thou. So I've been putting shims underneath the column at the back. So the shims that have gone in under there, nothing fancy. Didn't film it because it was fairly straightforward. It's just a case of undoing the nuts, tipping the head back. I was actually using timber underneath the head, just jacking the head down onto the table just to raise it so that I could slide the shims under both sides, nipped it back down, rechecked it, and it was just again an iterative process, changing out shim sizes until we'd got it right. So and then obviously the adjustments here on the head itself. I'm pointing and you can't see, apologies. So on the head itself there's a nut in there, a nut underneath and a nut this side, which obviously helps you tram, you know, it gives you your angle adjustment, but obviously to tram the head in side to side. So there was a bit of iterations of that as well. And basically where I finished up, over the sweep of the table, so if you look at how wide the table is front to back, I was sweeping the full width and obviously the same distance across this way, so you know, a good size sweep. I've got about 1.5 hours and that's as good as I can get it. So at the moment I'm comfortable with that. There is the potential with a lot of time and effort to get it better than that, but for now that's we'll live with that. So that's all set up, hopefully, ready to go. And then you'll see on the table is a vise. So I bought myself, you know, a couple of months ago now, in readiness for the mill coming, a vise. And again, I shopped around and I was looking at Abwood vices, you know, second-hand ones and all kinds of things. And I finished up buying a new one. It's an Asian import vise, but it's branded as high quality, you know, high precision rather. You know, usual Asian import stuff, sharp edges everywhere, so it's had a file all over it. The base has been stoned, and we've got it up on the table now. And I've done some basic checks on it. So I've run the clock across the bottom this way of the bias and across side to side all over it, just to see how parallel to the table it is, and it's very good. And I've run a clock up and down the fixture at the back, just to see whether there's any lean, and there is about 4 or 5 tenths of a thou lean. Now that could be the parallelism of the vice jaw, or it could be the vice itself. At a future point in time, that's an easy fix. We just pop the jaw off, check the jaw out with a micrometer, see if we can, or even on the surface table, and determine whether the jaw is parallel. If it is, then it's just a case of running an end mill across that back face while the thing's bolted to the table to square it all up. So either way I can fix that. The reason I went for this vise in particular was because it's got lots of options. So you can take the two jaws, you know, the two facing jaws off, and you can actually screw them to the back of the vise, one of them, and the other one to the front of the vise, which then gives you a huge capacity, you know, across the full width of the vise, or full length of the vise, apologies. It's got tapped holes in it in readiness for vise stops already. The thing's allegedly square, so it's a bit like a grinding vise, so you could sit it on its side if you wanted to. It's, you know, it's all been machined square. I've not checked the squareness, but so that's the vise that I've bought. It's a I forget, I think it's 3 3/4 inches or thereabouts in terms of width. Not quite got as much depth as I was hoping of the sort of jaw itself, and the base to the top of the jaw, it's quite narrow, and I don't have many parallels within that scope, so I've got to do something with parallels. So what we're going to do now is get the vise clocked in onto the table, and then we'll start thinking about putting some material in for a bit of a small project, and that project's going to be making some bespoke clamps for this vise, for this table, so that I don't use sort of stepped clamps and step blocks. You know, they're bespoke at the right height to clamp this vise down, so that's going to be the first real project for the mill. So I'll bring you back in a few minutes and we'll clock this vise in and get it fixed to the table. Alright guys, we're going to get this vise clocked in. So you'll have seen a million videos probably doing this. It's always best to get a bit of a nip on the vise just to make sure it's fairly sturdy. So we've got the clock on there now, so we'll just bring that up to a known position. Doesn't have to be 0, can be any line, but I'll use 0. Now I don't know whether my camera will pick the clock up or not, but we'll carry on anyway. So there's about 10th thou there. So I'm going to use something that I made in my very first sort of machining episode, which was this knocker that I made. This is what it was designed for, absolutely ideal for this. So I'm 10th thou plus on there, so we'll just knock that back to about the 5th thou mark, and we'll just run back. and that's within about 2/10. What I don't know is it going to move when we nip it down? It doesn't look like it is, which is good. So we'll give it a bit of a nip and we'll just check it again. Yeah, there's probably about 1/10 of movement on that, if that. Happy with that? Final check. Yeah, about 1/10, so that's perfect. Okay, what I'll do now is reposition and I'll take you through, well, I'll probably leave the camera here actually. I'll bring the stock over and take you through my thoughts on the clamps that I'm going to make and what I'm going to make them out of. So guys, I don't have a lot of stock yet. I've got some odds and ends, various just little bits and bobs of steel, and in that mix, and I don't know where or when I picked these up, these would have been off a fixture of some sort that was getting thrown in the bin, and it would have been off an incredibly large diameter part fixture, because you'll see there's actually a radius on the bottom of that clamp, and there would have been a series of these. I've got 8 of them that were round the part. I don't know what material they're made out of, no idea, but they're, you know, decent steel. So my thinking on this is I'm going to turn these things upside down. So obviously the clamps originally designed to be used in this orientation to obviously clamp back that way. I'm actually going to switch it round and I'm going to use them in this orientation on the machine bed, where this end here goes into the slot that's on the side of the vise, and this material that's at the back here, so all, you know, this, not so much this end piece but the rest of this section here, will be used as the support, milled to the right height down onto the table surface, so that you don't need any backing pieces on the clamps. So what I'm going to do is, first of all, I'm going to load these up into the saw, and I won't film this because it's just sawing, and there's plenty of those videos, and you know, even on my channel. So what I'm going to do on the saw is I'm just going to take this section off, this thin section. I'm just going to saw that clean off, so I've got a flattish edge here. The reason for that is, sorry, I'll get back on camera. At the moment, if I'm going to use this stock at the back here as the like the heel of the clamp, if you like, it's too high, so I'm going to need to machine some stock off, and by the time I've machined off what I need to machine off, I'm going to be left with a thin wispy piece here, which is no use. So I'm going to saw that piece off. There's more than enough thickness in this section for the heel of the clamp, so that's what we'll do. We'll machine the heel off there, and then in terms of the top of the clamp here, I'm also going to saw off, you can see how this clamp's been used. There would have been a jacking bolt at one end of it and the actual through bolt this side. I'm going to saw this piece off as well to get rid of this kind of hole there where the jacking screw was. So I'm going to saw the end off there, off 2 of them, and then what I shall do is when I machine you'll see that slotted, when I machine the clamps down, I'm going to machine this top surface until that slot just cleans up down to the bottom, and that's almost the right thickness to fit into the groove at the bottom of the vise at that point. So then what we'll do is we'll shape the front, so we'll shape you know, put 2 angles on the front edge, maybe an angle on the very front going down that way, and we're going to machine this back piece, as I said, to create the heel, and then the only other thing to do then is we need to open this hole out to 12mm to suit the 12mm studding on the machine. So I'm just going to get 2 of these sawn ready. I'm only going to make 2, I think, or do I make 4? I might actually make 4 while I'm at it. I've got 4 of these, so I might make 4. If I then put the vise in a different position on the mill, i.e. 1 slot further forward, there's enough space then to get two lots of clamps on, so I might make 4 while I'm at it. So I'll get those sawn off both ends, and then we'll come back when we're starting to set up in the mill. Right Right guys, I've done all the band sawing on the clamps. I took the material off that I wanted to take off, and some of you might be thinking, that bloke's crackers, he's just gone and bought himself a brand new milling machine that he can't wait to try out, and he's gone and chopped all the material off on a bandsaw. Why has he gone and done that? Well, there's a reason for that, and that is that I'm just starting out at the moment, so I don't have heaps and heaps of stock and metal around me, and you know, these are the sort of sections that I've chopped off, and I know it looks quite pathetic, but I've got 4 of those now, and I don't know whether at some point I'm going to need some packing pieces to go under some clamps or whatever else it is, but at the moment I'm just going to hang on to the bits. They're far more useful to me like that than they are as swarf that I've got to try and deal with and get rid of, so that's why I've done that, rightly or wrongly. So a couple of other things that I've thought about as I've been doing the band sawing. What I've done is deliberately chopped one of them slightly shorter than the rest, on this length here to this sort of face, and I'm going to machine that one first, and then I shall measure what that shortest length is back to this intersection here at the back of the sort of chamfer or the angle that's on the clamp, and that's the first face that I'm going to address, is this face. So I'm going to sit it on this face that I know is good. I've measured the width and I know that's parallel, so I'm going to hold it this way, end mill across the end, finish this one, measure the distance I've got, and then I shall make the other 3 to match that, and I know this is the shortest one because I cut it that way deliberately. Once I've got that side done, I'm then going to flip them all over and sort the top side out and finish them to a known width, and then I've got everything set up then ready to go and just finish this top face to the right thickness. And once I've done that, I'll flip them over and I'll finish this face to the final depth that I need for the heel of the clamp, if you like, so it's at the right height for the vise. So that's the procedure, that's the order of machining. So another thing that I'm just going to point out, I know in previous videos I've spoken about stripping the head down on the machine. That is still going to happen, but what I'm going to do and what I want to do before I do that is, and I'm not going to go mad here because I've only got this vise clamped with just 2 clamps at the moment, so I'm going to be taking it fairly steady anyway, but I just want to run this thing and I want to listen to it. I want to put it under a bit of load and just listen to, you know, how it performs and what goes on before I do the head strip down. That way when I strip it down I can, you know, not only have the visual of what's going on inside the head, but I can also have the sort of audio, if you want to call it that, of what the head sounds like under load and under, you know, so that would tell me if there's anything else I need to be looking at when I do the strip down. So that's the reason for just doing a small amount of work, plus not only that, I've done enough work on the mill already and I really want to get a cut on, so that's 2 reasons why. So I'm going to get set up now, we'll get an end mill in the chuck, we'll come back, we'll power it all up and we will go for the first cut and see, we'll see how it performs. Right guys, I've got a couple of parallels that I've had to clean up, clean the surface rust off. Like I said earlier, I'm quite short of parallels, but these are okay for this, where we are just now, so hopefully these will do for the remainder of this project at least. So what I've done, this is the short one, and I'm going to run across this edge and clean it up. I've stuck one in the other side of the vise just to make sure the vise clamps up evenly and doesn't tip one way or the other. This is the first time I've had anything in this vise, so we'll see how it performs. Just got hold of him. So I'm going to run at 960 RPM, and we'll see how we get on. I've got a 12mm carbide end mill in there, so it's not the highest speed, but I'm probably going to avoid that until I strip the head down. I don't know whether that's going to make any difference or not. So what I've done is, I did some clock checks as well, by the way, on the spindle. So I've clocked, when I did the shimming of the column, I've clocked the inside of the Morse taper 4, and there's 0 run out, which is really good. I've put this ER32 holder in I've clocked the outside of the R32 holder, and I did that before I did any of the tram checks, just to make sure that I wasn't incurring any error from the run out of this. And there's 0 run out on the OD of that as well, which is good. And then I did a clock on the inside of the taper of the ER32, and I've got a 0 run out that I can detect on that as well. So hopefully all of that's very good. So we've got that clamped in, we've got the cutter in, so this is it. We'll take our first cut and see what happens. Well, there's the first chips, guys. Seems to cut okay. No strange noises, nothing funny going on. So I'm just going to now repeat that. I'm going to measure that now and see what that dimension is. We'll deburr it. I'm going to make a note of the dimension, and then I'm going to make all the others to the same thickness on that. You know, between the end of the end that I've just machined, and possibly either the transition here or the original clamp face underneath. I'll just check them all out and see which is the best face to come off for that measurement. Right guys, what we're going to do now is I'm going to use a fly cutter. So this is one that I made as an apprentice back in 19 canteen. It was red rusty up until a few minutes ago, so I've just given that a clean up. We put it in the ER chuck, and it's just got a carbide insert screwed in. Very crude, but they work very well. Well, certainly it did 30 years ago. And the reason I'm using this and slightly different method, so what I'm going to do now is, where's the vise? There it is. So I'm actually going to cut across the top of the clamps, and I've got the shortest one in the vise there at the minute. Again, for a reason, I can set my height on this shortest one, and then I can run all of the rest of them through at the same setting, so they'll all end up the same length. So that's the plan. The reason I want to use the fly cutter is because I just want to, again, before I strip the head down, I just want to test this with an intermittent cut, really. I could have done these the same way I did the other end with a flank mill on an end mill, but I just want to try an intermittent cut and just see what kind of noises we get from the machine and from the head with an intermittent cut. So we'll give that a go. So we've got that sat on some small parallels at the bottom. It's in the vise, it's clamped up tight, so we'll give that a go and see what we get. So a bit clattery, but I think that's more probably that carbide insert than anything. I've not done anything with it. I've just it's kind of hand ground anyway, but it's coped all right. It's put a decent finish on there. So we'll persevere. I'll get another one up in the vise, and we'll stick it on time lapse and cut the rest of them. Right then guys, we're back. We've exchanged the fly cutter for a 16mm solid carbide multi-flute end mill. These clamps are too wide as they stand at the minute, so we're going to remove some material from the side. Now I could have persevered with the fly cutter, but the whole thing that I'm trying to do here is just test the mill out in all its different modes. So this is going to be taking a good inch deep at the back at the highest point, flank cut on the side of these clamps, And I forgot to mention this stuff is, well, it's known in the UK as D3, so it's tool steel. So it's not. I'm not giving it an easy test for its first go. But you know, that was the whole thing really. I wanted some clamps for the vise, and I wanted to just test the thing out, you know, and just see how it performs. So what we're going to do now is give this a whirl. What I'm expecting here is some chatter and vibration, maybe. We'll see. But this is a brand new, you know, it's pretty much brand new solid carbide end mill, so it's nice and sharp. So we'll give this a run and just see if we can take 2 or 3 millimeters off each side of the clamps, and see how that goes. So I'll bring you back when we're cutting. Right guys, we've touched off, and I've wound on 3/4 of a millimeter cut. So we'll try that. You know, it's a decent test, and we'll see how that goes. Well, a fair test, I think. It's grumbling a little bit, but I kind of expected that. Most of the noise is coming from the bass, and you can hear it. You know, the whole thing rings. So there's a bit of work required with the bass, I think, just to try and deaden that somehow, even if it's filling it up with, you know, something with some mass in it. I don't know what. I'll give that some thought, but that cut reasonably well actually, despite all the noise. As it got to this end bit, it did start to try and grab a little bit, but that was a 3/4 of a millimeter cut, so in tool steel. So it was, you know, for a small hobby size mill, I think that's in tool steel, that's reasonably impressive. So I'm going to dial the cuts back a little bit, probably to 1/2 mil, and we'll just take a couple more passes off here, and I'll put that on time lapse. Guys, I've just loaded the next side to do on this particular clamping, and I just thought it was worthy of a quick discussion. What I'm finding is this is getting quieter and quieter. I've got rid of the parallel now, I'm just coming straight off the base of the vise. But even when I did the first one like that, I was still getting the sort of squealing and vibration that you get, and that you heard on the first go. What I'm finding is it's getting quieter and quieter now, and I know exactly what that is, and it probably explains why this carbide tool was being thrown away. So when they grind these things, when they come off the grinder, the edges are absolutely razor sharp, obviously because they've just been ground. And typically what they do is they run them backwards in crushed walnut shells to put what they call an edge prep on. So, and what that does is puts like a 4, 5, 6, 8, possibly maximum micron sort of edge prep right on the very sharp razor edge. And what you tend to find is with brand new end mills that haven't had that edge prep put on them, when they're really keen, they will squeal, and then as you start using them, they start bedding in, and you take that real sharp razor edge off, they quieten down. So it's probably what's happened with this one is it's missed the edge prep, which is why it was being thrown away, because it was no use for the intended purpose. So that was one thing. Second thing is, you'll always see me when I'm milling, if I'm flank milling like this and it's reasonably tough material like I've got today, you'll always see me doing it on the right hand side of the vise if I'm conventional milling, and the whole reason behind that is, as you're cutting, you're obviously cutting, the vise is coming this way, which means your cut's going that way, which means all your cutting force is up against the fixture of the vise, whereas if you cut on the left hand side of the vise, if you're conventional milling, all your cutting forces are going against the moving jaw of the vise. And it'll work both ways, but the most solid setup is always to keep your cutting forces wherever possible aimed at the fixed jaw. So I've got another cut set. It's a 1/2 mm depth of cut, full height, and we'll just go and see if it proves me wrong. There you go, guys, that's the difference with an end mill that's got the sharp edges sort of taken off it, completely different. So that's cutting really well now, so I'm going to carry on. I'll not film the rest of it because it's all the same, and I'm going to bring all 4 clamps to the same width. Basically I'm taking 2.5 mm off each side to reduce the width by 5 mm overall. So I'm going to carry on doing that, and then we'll bring you back at the next operation.